All right, so in this video, we're going to go over the operations of addition, subtraction, multiplication, and division of fractions and some decimals. Okay, so let's go ahead and just start with part 1a. This is 3/4 minus 5/6. And essentially what we need to do here to subtract these two fractions is get a common denominator. So the common denominator is just the least common multiple of the denominators. And that is, in this case, 12. Some people sometimes multiply the two numbers together, the two denominators, to get 24. And you can use the number 24, which I'll do in this case. So I'll multiply both the top and bottom of the first fraction by 6 and the second fraction by 4. But 12 is the least common denominator, so it'd be more efficient to do 12, but just to show that it works with any common denominator, I'll use 24. And so if I multiply, I have 18. Here I just multiply across. 6 times 3 is 18. 6 times 4 is 24. Minus 20 over 24. And then we subtract the two fractions by subtracting the numerators and leaving the denominator the same. So here we get negative 2 over 24. And if you don't use the least common denominator, but just a common denominator at like 24 here, then you'll probably have to do a little bit of reducing at the end. And here we can see that there's a common factor of 2 in the denominator and in the numerator. So I just divide both the top and the bottom by 2, and that gives me an answer of negative 1 over 12. So this is how we subtract two fractions. To add fractions, I'll do the addition problem next, which is 7/8 plus 5/4. Here, this is a common question where students will sometimes not see the least common denominator. Here, the least common denominator is 8. So really, we only need to multiply the second fraction by 2. And that's what we'll do this time. Yeah, let's do that. Multiply by 2. And if you want to think of multiplying the first fraction by something, you can multiply it by 1. 1 over 1. Okay, so when we multiply 7 times 1, 8 times 1, plus 5 times 2, 4 times 2, we have a common denominator, and we can just add the numerators and keep the denominator the same. So there's our answer. So for adding and subtracting fractions, we need a common denominator. Now, when multiplying or dividing fractions, we don't need a common denominator. So we can show that here for 1b. Let's do negative 5 times 2/9. So when you're multiplying and dividing fractions, it's good to write both of the numbers as a fraction. So negative 5 can be thought of as negative 5 over 1. And we've already done multiplication of fractions in the previous problems. When we multiply two fractions, we just multiply the numerators together. So that would be a negative 10. And the denominators. And that gives me a denominator of 9. So our answer here is negative 10 over 9. Just multiply numerators and multiply denominators. Next, let's look at division of fractions. Is it 21/4? Okay. Let's do that. Negative 7/3 divided by 21/4. Okay, so how do you divide two fractions? We divide two fractions by just, sometimes people say keep, change, flip, keeping the first fraction the same, changing the operation from division to multiplication, and flipping the second fraction. So making its reciprocal, 4 over 21. And then we can just multiply straight across. Now, we could multiply the 7 times the 4 and the 3 times the 21 and just find the products and then reduce. But if you notice there's a common factor, like in the 7 and the 21, 21 is 7 times 3. So I can cancel out the 7 there, leaving a factor of 1 in the place of each of those. and then just multiply across. So that would give me 1 times 4 on top. That would be 4. And then 3 times 3 on the bottom, that would be 9. And there was a negative out front, so that negative can be put on top, on the bottom, in front of the fraction. It's all the same thing. So the answer could be -4/9, or if you like, the opposite of 4/9, or if you like, 4 over -9. These are all the same. Okay, so there we go. I do want to show, well, what if we had just multiplied the 7 and the 4 together? Then we would have had a -28 over 63. And there, it might be a little bit tougher to, oops, over 63 is what I said. At that point, the numbers are really big. Can it be reduced? Well, we can think about it. Yeah, and if you remember your multiplication table, that 7 divides into each of these numbers. But rather than dealing with these large numbers here, before doing a multiplication problem, you can also try to reduce, you know, uh, before actually carrying out the multiplication. Okay, so um, that's adding, subtracting, multiplying, and dividing fractions. And then the last two problems here are the last two problems are on multiplying decimals. Let's take a look at F first. This is 38.9 divided by 10. And when you divide by a power of 10, the rule that we're trying to get across here is that you can just move the decimal place over one place to the left, and that will be essentially as if we carried out the division by 10. So the answer is 3.89. All right, so that's the rule there for part F. Now for part E, the rule we're trying to get across in 1E is actually when we multiply, let's say, a power of 10, like 10 to the third power, or 1000, times 6.4. In order to do this, you move the decimal place over 1, 2, 3 places. Uh, so 1000 times 6.4 is 6,4, and then those empty spots get zeros. So 6,400 would be our answer. Now, in this problem that I got here, it's actually not a power of 10. It's 75 times 6.4. So we could go over that as well. 75. Let's see if I can remember how to do this. Times 6.4. So we just carry out the multiplication, and then the final answer is going to have the same number of decimal places as the sum of the number of decimal places that we have here. So we have 0 decimal places in the 75 and 1 decimal place in the 64, 6.4. And so our answer should have 1 decimal place. So let's go ahead and just carry out the multiplication. 4 times 5, that's 20. 4 times 7 is 28. Plus 2 more is 30. Then we move over to the next number here. We're multiplying the 6 through now. We can put an X because now we're in the tens place, or we're in the next place value. And so we'll multiply the 6 by the 5 to give us 30. So 0, 3. 6 times the 7 is 42, plus 3 more is 45. So 45. And then we add down 0, 0, 8, 4. And then we put a decimal point here, 1 place in, because we had 0 decimal places in the first number, 1 decimal place in the second number. So this, after we add down the columns, we should have 1, the sum of these two numbers, number of decimal places. So 1 decimal place gives us 480.0. Okay. All right, so that was problem number one. I'll stop the video here and then make a separate video for the other problems.